Today we're going to integrate cos theta over 1 plus sine to the 5 theta plus square root 1 plus sine to the 10 theta between minus pi over 2 and pi over 2. First thing we're going to do, we're going to make x sine theta. And we're doing this so we can get rid of the cos theta that's on the numerator. So after doing the substitution, we get minus 1 on 1 as our new bounds, 1 on the numerator, and then 1 plus x to the 5 plus square root 1 plus x to the 10 on the denominator. Now, what we're going to do now is we're going to consider the following product. 1 plus square root 1 plus x to the 10 plus x to the 5 and 1 plus square root 1 plus x to the 10 minus x to the 5. And you're going to see this is the difference of two squares. So you can write it as follows. Minus x to the 5 squared, which is x to the 10. And then if we expand out this bracket, we get 1 plus 2 square root 1 plus x to the 10, and then 1 plus x to the 10 squared. So that's plus 1 plus x to the 10. And you'll see that these x to the 10 terms cancel out, and we're left with 2 lots of 1 plus square root 1 plus x to the 10. So we're going to do this to simplify our integral. So between minus 1 and 1, we multiply the top and the bottom by 1 plus square root 1 plus x to the 10 minus x to the 5. And then on the numerator, when we multiply them together, we just get what we just worked out just now. So on the denominator, we're going to get 2, 1 plus square root 1 plus x to the 10 dx. Now, you may see where this is going. I'm going to split this fraction into two fractions. So we have 1 plus, actually first I'll take out the half as well, to make things simpler. So this is one of our fractions, and you'll see this just simplifies to 1. And our other fraction is x to the 5 with a square root, over 1 plus square root x to the 10. Now what you might notice is that this fraction here is just equal to 1. And what you might notice about this cheeky function over here is that it's an odd function. And since we're integrating between minus 1 and 1, this term here will just integrate to 0, so you don't need to consider it. So what we're left with is half the integral between minus 1 and 1 of 1 dx. And then evaluating this, you end up with 1. So that's our answer.